Okay, welcome everybody to the notes on arcs and chords. We will take a look in this section at different kinds of chords and things that we can figure out or do with those. It's going to be exciting. It's a snow day. I just finished my shoveling. I got a nice hot cup of tea sitting here with you guys. So I don't know how this could be any better. Let's start with the definition of a chord. A chord is a segment with its endpoints on the circle. Pretty self-explanatory, pretty simple anyway. In a circle or congruent circles, two minor arcs, remember minor arcs were arcs that were less than 180 degrees, two minor arcs are congruent if and only if their corresponding chords are congruent. So pretty simply looking at this picture, we're saying that if AB, and I'll mark it congruent, if AB is congruent to CD, then the two arcs AB and CD are also congruent. Really simple. Okay, let's take a look at an example problem right here. I don't know what all that is down there. Let's get rid of that. So we're telling you AB is congruent to CD. The background noise you're going to hear today is my family. At some points it's going to sound nice and peaceful, and at other points it's going to sound like we're all at the zoo. Anyway, AB is equal to CD. We're going to find X if arc AB equals 2x plus 3 and arc CD is 23. So really simple, since this chord is congruent to this chord, the two arcs are also congruent. So we can say that 2x plus 3 equals 23, solve for X, and it's 10. Easy peasy. Let's take a look at the next page. Here, a little bit more complicated problem. In a circle, if a diameter or radius is perpendicular to a chord, so perpendicular means 90 degrees, that it intersects at a 90 degree or right angle, to a chord, then it bisects the chord and its arc. So if this right here, this spot right here is 90, what we're saying is, we're saying that if BD is perpendicular to AC, which it's marked perpendicular right there, then AD, arc AD, arc AD is congruent to arc CD, and that AF is congruent to FC. So we have this congruent to this, and we have this arc right here congruent to this arc right here. That's what we're saying. Michaela, say hello.
Hello.
All right. So let's look at a problem. We have BF, there are those rectangles again, haunting our existence. If BF is 18, so from B to F is 18, and FD is 2, what is AE? All right. So good question, right? Let's see what we can label. Okay. So we have BF. That's from here all the way to here. That's 18. This distance right here, all the way to there. That's 18. And FD, this distance right here, that's 2. And the question is, how much is AE? All right. Well, this is a diameter right here, okay? And if this diameter is a total of 20 and AE is a radius, AE is half that, and that's not good. There we go. AE equals 10. Okay, really pretty straightforward problem. Labeling these circles as we go is really a good idea. Here we have EF, so that's this distance right here is 11. The radius of circle E is 17, so this is 17. What is the measure of arc ADC? So we're looking for, this is a pretty complicated, in-depth problem here. We're looking for the measure of this arc. Okay. Now what I need to remember is, I need to remember that central angles are equal to the arc. So if I can figure out the measure of this angle, that's the same as the measure of this arc, and we said that if these two are perpendicular, I can double it and get the measurement of the whole. So we have a hint over here for us. It says, how can we find missing angles of right triangles? So we're trying to remind you that in this problem, you're going to use trig. We're looking for this angle right here, this angle X. Again, we're looking for that angle because it's equal to this arc, which is equal to this arc. So once we find X, we're going to double it to get the whole thing. So, trigonometry. I'm going to use, I have an adjacent side and the hypotenuse, so I'm going to say the cosine of X equals 11 over 17. All right. take a second, get out your calculators, and let's do some trigonometry. Alright, so I got my calculator out. Remember, when we're looking for the angle, we're going to go shift cosine, okay, the inverse trig function, and then depending on which kind of calculator you have, that's one too many ones. Depending on the kind of calculator you have, it changes the buttons that you push. Well, let's just go ahead and round this to the nearest tenth. So that would be 49.7 degrees. So x equals 49.7 degrees, and that's this angle, which is equal to that arc because this is a central angle. The vertex is on the center of the circle. So this is 49.7, which means that's 49.7. So the measure of arc ADC, that whole thing, is 49.7 times 2, which is 99.4. Alright, let's take a look at another problem. In a circle, or in congruent circles, two chords are congruent if and only if they are equidistant from the center. Okay, so two chords are congruent if and only if they are equidistant from the center. Alright, let's take a look at what that means in this scenario right here. If EF and EG are congruent, so if we can mark these two congruent, these two little pieces right here, then both arc AD and arc BC are congruent, and chord AD and chord BC are also congruent. So a problem with that kind of scenario would look like this. EF, the problem tells us EF is equal to EG. It tells us that AF is 8. It tells us that BC is that 2x plus 4 or x plus 4? What is that? Yeah. It tells us that BC is 2x plus 4. Okay? So this whole thing is 2x plus 4. So we know that this whole thing is 2x plus 4. We also know that AF is 8, then FD is 8 also from one of the previous slides, and that is that if a segment is perpendicular to a chord, it bisects it. So now we have these two chords here are congruent. So I have 16 is equal to 2x plus 4, so x equals 6. And that's all there is to that problem. Now, there are a lot of things you have to know, but there aren't a lot of steps to the math. Let's take a look at some more. Practice with chords. So in circle X, so this circle right here, we're going to give you some distances. So AB is 30, CD is 30, and CZ, arc CZ, this right here is 40. So let's find some measures. So if AB is 30, then AM has to be 15. Let's do something about my handwriting here because it is bad. That animal sound you hear is Madison Nemero. CN, if CD is 30, CN is also 15. Arc DZ is equal to arc CZ, so that's 40. And here we're not really doing any math. Here's the extent of the math we're going to do. If these chords here are congruent, then the arcs are also congruent. So if CD is 80, then AB is also 80. The extent of the math we're doing is we're going to multiply something by 2 right now. It's just a matter of knowing the facts. MB is half of 30, so that's 15. ND is half of 30 also, so that's 15. At this point, we can just start doing that. CD is 80. And YB is 40. So pretty simple stuff if you know your facts. In circle F, we tell you that FH is congruent to FL, so that's also 8, and that FK is 17. And then we ask you to find some measurements. So LK, well, this is a right triangle. So to find LK, I'm going to do 17 squared equals 8 squared plus LK squared. Okay, that's 289 equals 64 plus LK squared. You end up getting LK squared equals 225, and the square root of 225 is 15. JG, if this is 15, then this whole thing is 30, and JG and KM are congruent. So this is 30, Km, like we just said, is congruent to JG, so that's 30. And JH, let's see, JH is this piece right there, so that's 15. Easy enough. Just knowing the relationships is a big deal. Let's take a look at here some definitions. This is a tangent. A tangent is a line or segment that intersects a circle at exactly one point. This is not the tangent that you try to get, your substitute teacher to talk about so that you don't have to do any work. Not that you guys would ever do that, because you're all very studious. Studious is an I-O-U-S word. It's a good word. So that's what a tangent is. It intersects a circle at exactly one point, a line or a segment. And then a secant is a line or segment that intersects a circle at 2 points. So difference between a chord and a secant obviously is a chord. The endpoints are on the circle. A secant actually goes through the circle. Okay? So there are those two. From the picture, let's do some identifying. Let's identify a chord. A chord here, and there's more than one answer. So we could have AD. That's a chord. AC is a chord. So more than one answer there. That's not an L. Thank you very little. Okay. A tangent line. The tangent line here would be FD. Okay, so a secant line. A secant line is, again, a line that goes through it, so that would be AD. An arc of 180 degrees. I want to make sure that I always identify the diameter. The diameter's here, so an arc of 180 degrees. It doesn't matter which way I go, from B to G, or from G to B, or from B to G. It doesn't matter, as long as I know that from B to G, that arc is half the circle, and half the circle is 180 degrees. A radius, I could say EB, or I could say EG. They both work. And a minor arc, there's a lot of them. BA, AG, GD, DC, CB. Those are all minor arcs. I'm going to go ahead and list AB as my minor arc. And that's it for the notes. Stay tuned via Twitter and YouTube and Remind 101 and School Fusion and all the ways I have to get a hold of you. With all the snow that we've had, there's a chance that we'll do more notes online over this break. Feel free to let me know how it's going. If you thought this was easy, go ahead and try 8D and let me know on Twitter or the comments below on YouTube if you need help, and I'll see if I can't help you out online best I can. Quick public service announcement from Michaela and Emerald. Michaela?
Happy Valentine's Day, everybody. Hope you have a good day.
And a happy Valentine's Day to all of you out there. That's it, guys. Have fun. Be safe. Enjoy the break.